Ever had issues with your laser cutter, laser engraver, not cutting or not engraving evenly? I'm going to show you a quick check to determine if laser alignment is your problem. Stay tuned and learn how. Before starting a big cutting job, I always like to check the alignment of my laser. If it's out of alignment, then I'm going to end up wasting material. Let me show you how to go about checking it very, very simply. All we're going to need to do this test is a little bit of masking tape. And don't forget, always wear your laser safety glasses. These are made to work with CO2 laser. Make sure that whatever laser that you use, you've got the appropriate light filtering glasses to protect your eyes. And what I do is I just tear off a little small piece that I can put on the opening in front of the mirror on the laser printer. Then what we'll do is we'll use the laser's controls to be able to pulse, real short pulses of the laser, to be able to create a mark on this tape and to check the alignment. So let's get started. What I do when I'm running this test is I want to make sure that the laser fires the same through the same path through all of the mirrors in the same exact way across any position on the laser printer cutting bed. When I do the test with the tape, what I'm doing is making sure that that laser is firing through the exact same position in the mirror. So it's making a hole in that, and in any position that I put the laser, it's firing through that same exact hole. That means when it hits that last mirror, the beam going down is going to be in the exact same position. If the mirrors are out of alignment, my beam is going to move around, and the final result is as the head moves around, it's going to get out of position and back into position, or out of alignment, back into alignment. And what that can mean is that if I'm trying to produce a precisely measured object, like making a ruler, and you need that ruler to be accurate all the way across the length of the ruler. If the mirrors are out of alignment, the measurements will get increasingly off as you burn across the length of the ruler. So alignment is important for reproducibility. Alignment is important when you're trying to make parts fit together. And that's really why I do this test. I want to make sure that things are aligned correctly, and that avoids a lot of frustration down the road as I try to assemble parts together, and I try to have things that fit very, very precisely. My laser tube is in the back of this machine. So what happens is the laser will fire, it'll hit the first mirror, it'll reflect down, it'll hit a second mirror that's in the gantry, and then it'll reflect across and then hit a third mirror at a 45-degree angle in the head, and then that points the beam down onto the cutting surface. When I do this test, what I'm going to do, of course, is I'll put my tape over the opening of the laser head, and that's really position number one. So I'm going to use 3 different positions. So what I'll do is I'll start in position 1, fire the laser, pulse the laser, get a little dot on the tape, then move it in close to this mirror, fire it again, and hopefully if things are in good alignment, then that will go through the same hole, or the mark will be on the same position that it made out here. And then what I'll do is move it to the closest to the laser corner, the upper left, and then I will pulse it again and make another mark on the tape. If everything is in good alignment, then that laser beam is going to go through the same hole in the tape in any position, and in fact any position on the bed. And then all you have to do is just make sure that the final mirror is shooting the laser through the actual hole in the bottom of the laser head. And as long as you're doing that, then you're in good alignment, and that's going to mean that you're going to get even cutting, even power in any position across the bed. If you're out of alignment, where you have two holes in the tape from position 1 to position 2 or position 2 to position 3, and what's going to happen is the angle of the beam is going to change as you move across the cutting surface. And if the angle of the beam moves a little, that's going to induce some of that error that we were talking about, where my precision measuring from my translation from the CAD drawing to what gets cut is off. Or in the worst case scenario, on the laser head, it moves so far that it hits the side of the cone and misses the opening. When that happens, then either you can lose all the power of the laser, or the laser can get reflected, and you start to get real big changes in position, or in some cases you can even get a double image coming out of it. So a little bit going through the hole, a little bit being reflected, and you end up with some weird double lines out of the thing. If you're trying to burn a spot, you could end up with a crescent-shaped spot as opposed to just a good, small, tight, round dot. So that's what I do. Positioning of the laser, I should be able to really move it to any position and everything will line up, and that laser path go through the same hole every single time. I hope you find this tip useful as you work with your laser cutter. Thanks for joining me in this video.
This is Dave in the shop.